Alright, in this video we're going to talk about logarithmic functions. So everything you ever wanted to know about logarithms but were afraid to ask, we're going to try to cover in this video. And there's quite a few properties, so it may take a few minutes here to get through it. So one thing, the graph of a logarithm. So a logarithm looks like y equals log, and then we call it a base a of our variable x. And this base a can be any number greater than 0. We don't let it equal 1. But the most important case is going to be when this base is greater than 1. And if this base is greater than 1, this will be a graph of a basic logarithm. So this is the point 1, 0. So all logarithms will go through 1, 0. It gets close to the y-axis, but it never actually touches it. And then it keeps growing, but it definitely kind of tapers out. It stops growing very quickly. So that's the basic graph of a logarithm. Okay, so what the heck is a logarithm? Well, it's kind of a difficult question to answer, I suppose. Computationally, the way that you'll want to deal with logarithms, suppose I have log base a of x equals y. I can turn this into an equivalent exponential, and you write that as a to the y equals x. So this is definitely one of the first little rules that you'll want to commit to memory for a logarithmic function. So let's do a couple examples of these here real quick. Suppose somebody said find log base 10 of 1000. Alright, well, so log base 10 of 1000, this is just some number. I'll call it x. I don't know what it is. But notice this pattern on going from a logarithm. It says if you take this base a and raise it to that power y, you'll set it equal to x. So equivalently, it says I can rewrite this as 10 raised to the power of x equals 1000. Well, don't say it's 10 times 100 because we're not multiplying. You have to think about exponents. So 10 to what power is 1000? Well, 10 squared is 100. 10 cubed is 1000. So it turns out that x has the value of 3. Or we could say likewise that log base 10 of 1000 is a fancy way for writing the number 3. And logarithms, to me, almost any time I see them, I'm definitely thinking about the equivalent exponential form in my head. Let's do one more here. Suppose I have log base 5 of 1 over 25. So same way, this equals some number x. Well, I can rewrite it as 5 to the x equals 1 over 25. But notice I can write 1 over 25 as 1 over 5 squared, right? 5 squared is 25. And remember, through properties of exponents, I can bring this 5 to the numerator by making the exponent negative. So if you look basically at the left side, it says 5 raised to some power has to equal 5 raised to the negative 2. Well, in that case, it must be the case that the powers are equal, so we must have that x equals negative 2. Okay, so this power up here has to equal this number, so x equals negative 2, and we're finished. So again, log base 5 of 1 over 25 is a fancy way for writing the number negative 2. Alright, so kind of the first basic properties you'll want to know with logarithms. The next three important properties that are worth remembering are going to be kind of, I don't know, I always consider them kind of the algebraic rules of logarithms. So more rules. It says if you have a logarithm, regardless of the base, it says if we have two things being multiplied, you can break up the logarithm, but it doesn't become the logarithm of one times the logarithm of the other. It becomes the logarithm of one thing plus the logarithm of the other thing. Likewise, if you have division, well, multiplication goes to addition. You may be able to guess that division becomes subtraction. So you'll get log base a of x minus log base a of y. And the other property says if we have something raised to a power, in this case x to the n, there's a rule that says this power can come out front as basically as a factor. You're going to now be multiplying by that power. And notice it's now gone on the right side. So a few more rules that you're going to want to remember with logarithms. If there's a plus or a minus inside the parentheses, you can't do anything with it. You just have to leave it just like it is. So the properties only apply when you have multiplication, division, or one of these powers. Obviously, since there's an equal sign, you can go from the right to the left as well. If you have a logarithm of one thing and a logarithm of another thing, if they're the same base, in this case a, well, you can rewrite the addition as a single logarithm as multiplication. So let's do one of these. Suppose we want to expand let's do log base 2 of x cubed times y over z squared. Well, you could do this in one fell swoop. I'm going to do it in a couple steps. Again, it says if you have whatever's on top, you make it log base 2 of that minus log base 2 of the bottom. So I'm going to get log base 2 of the top, x cubed times y, minus log base 2 of z squared. And I have to be careful here. I can't pull the 3 out because everything's not being raised to the third, just the x. But now I do notice that I have multiplication, so I can break up this first one as addition. And I am going to use this property on my second one over here. It says if you have something raised to a power, you can pull that power out front. So I'll get minus 2 log base 2 of z. And the last thing I'm going to do is pull out this 3. So I'll have 3 times log base 2 of x plus log base 2 of y minus 2 times log base 2 of z. And that's now nice and expanded. The instructions could have started you with the thing at the bottom, and they could have said, well, rewrite this as a single quantity. Basically, you would just reverse the steps. You would take any coefficients and put them up as powers. So all the coefficients would go up as powers. And then if things are separated by a plus, again, they have to be the same base, and they all, in this case, are. If things are separated by a plus, they would become multiplication. And then if things are separated by a minus, you just end up dividing. So it would be pretty simple, I hope, to go back the other direction as well. If this is the first time you've seen logarithms, or it's been a while, it may not be quite so simple. They can definitely be a little confusing. But it's one of these things. Once I think you do a few of them and get a handle on them, you'll be okay.